Hello, graphics viewers. It's me, April, again for project number 6, Cat Menagerie, or as I guess I called it, Messing Up the Cat, for CS457 Computer Graphics Shaders at Oregon State University. So, today's object is the cat. And our goal was to do as weird of things as possible to our cat using shaders. And so I did something pretty funky. I turned it into a rainbow spiral peeled cat. So I don't think he's feeling too well. But yeah, so the way I did this was I got inspiration from Professor Bailey's fragment shader code that he wrote about in his book, Graphic Shaders Theory and Practice. The code was a derivative of J.E. Connett's circle squared algorithm. So it used this really cool and pretty simple algorithm to, I guess I'll show you in the code, but it keys off of the circle equation for every S and T point along the surface, and moduluses the location with a user inputted value, and depending on the modulus's result, it either colors that fragment with U color that you can pass in, or it discards the fragment. And if not, then it'll color it with a different color. So what it ends up doing is it colors really cool algorithmic concentric circles on your object. And I ended up distorting the circles by changing the powers. But yeah, and so the coolest thing is, I guess you can get into the code and see how cool it is, but I just like how it turned out, where you can just adjust everything and it looks really weird. So that was a long-winded rant. Let me show you what it looks like. So here's what it looks like when you're keying off the actual object's S and T coordinates, so it goes around the object itself. If you switch to use the screen coordinates, that's where you actually see the coordinate circles working. So this is what it's supposed to look like. I just think it looks cool when it looks like a shredded peel. Yeah, so you could also make it not discard fragments. So when I check this, it doesn't use discard, and instead it uses the color black for the negative space. And so the cool stuff comes where you change the modulus up and down. The higher your modulus, the more black or discarded areas there will be. And when you change this value, you start getting super wacky circles. So yeah, really trippy. Whoa. And yeah, that's pretty much it. The way I got the background color, all of the rainbow, is I took the current S and T location, and since that value is constantly changing, in my function I had it changing from a value of 0 to 1 after I pass it through the modulus, and so I just pass that into a rainbow function, takes that value going from 0 to 1, pops it into a few sign functions for x, y, and z, or RG and B, sorry, and then outputs this rainbow depending on where it is. So, whoa! Yeah, I'll just change it a few more times just to show you all the variants that these coordinate circles can produce. I wish the resolution was a little higher, but yeah, now you can see how cool it is. Whoa! But yeah, that's it. If you want to see the actual code, then you could follow the link. I have the link in the caption, or not the caption, the description of the video, and you can see the GitHub code. That's where all the magic's happening. But yeah, thanks for viewing my video, and have a good rest of your week.